Picture this. It's mid-morning, somewhere in ancient Southeast Asia, around 60,000 years ago, and a young man is crouched beside a cluster of unfamiliar mushrooms growing out of a rotting log, turning one over in his hand, genuinely torn about what to do next. He's hungry. The mushroom looks fine, smells fine, honestly looks a lot like another mushroom his group eats regularly back near camp. But it's not quite the same. The gills are a slightly different color. The stem feels a bit too smooth. And somewhere in the back of his mind, without him fully understanding why, a quiet, nagging discomfort tells him this might not be the same thing at all. He sets it down, untouched, and keeps walking, even though his stomach is loudly disagreeing with that decision. That single moment, repeated in some form by ancient humans across virtually every environment on the planet, across tens of thousands of years, represents one of the most consistently underrated survival skills our entire species ever developed. So here's the question. This video exists to dig into properly. How did ancient humans actually know what food was safe to eat in a world with absolutely no labels, no internet, no friendly podcast warning them about toxic berries, and no guarantee that the next bite wouldn't be their last? Stick around because the answer involves real, fascinating biology, some genuinely clever cultural problem solving, and an uncomfortable number of people throughout ancient history who almost certainly had to learn the hard way so everyone else didn't have to. Let's start with the single most important and, frankly, most brutal truth underlying this entire topic. A lot of this knowledge was paid for in actual human lives. There was no shortcut around direct trial and error in the earliest stages of figuring out which plants, fungi, and animals were safe to eat. Somewhere in deep ancient history, someone, probably many someones across many different times and places, ate the wrong root, the wrong berry, the wrong mushroom, and got violently ill or died as a direct result. This wasn't some isolated tragedy. It was almost certainly a recurring, expected cost of survival in a world where the only way to truly know if something was edible was to actually eat it and see what happened. Researchers studying the history of human diet sometimes refer to this informally as a kind of biological trial and error process, and it's exactly as unforgiving as it sounds. But it's also the foundation everything else in this video builds on, because that hard-won, often fatal information didn't simply disappear once the person who discovered it was gone. It became something far more valuable, a lesson. Let's talk about the human body's own built-in safety systems first, because before we even get to learned knowledge and cultural transmission, ancient humans had some genuinely impressive biological tools working in their favor from the very start. Bitterness detection represents one of the most important of these, and it's worth understanding why. A huge proportion of naturally occurring toxic plant compounds taste intensely bitter to humans, and our sense of taste evolved specifically to detect and react negatively to that bitterness as a built-in warning system. This isn't some learned cultural preference, it's a deeply rooted, largely innate biological response, with infants showing clear aversion to bitter tastes from a remarkably young age, well before they could possibly have learned anything about which specific plants happen to be dangerous. This means ancient humans, completely independent of any taught knowledge, almost certainly avoided a meaningful percentage of genuinely toxic plants simply because their mouths immediately, instinctively rejected them as unpleasant, long before any conscious reasoning about safety ever entered the picture. Smell worked similarly, providing another layer of built-in instinctive protection. Spoiled meat, certain toxic plants, and various dangerous substances frequently produce distinctive, unpleasant odors that trigger an automatic disgust response in humans, again largely independent of specific learned knowledge. Researchers studying disgust as a psychological and evolutionary phenomenon have specifically pointed to this kind of automatic aversion to certain smells and textures as a genuinely ancient, deeply rooted survival mechanism, one that almost certainly predates our specific species and extends back through a much longer stretch of primate evolutionary history. Ancient humans encountering an unfamiliar food source weren't starting from a position of complete, helpless ignorance. Their own bodies were actively, automatically screening out a meaningful percentage of genuinely dangerous options before any conscious decision-making even needed to happen. But here's the thing about these built-in systems. They're genuinely useful, but they're far from perfect, and this is exactly where things get more complicated and more interesting. Plenty of dangerous plants and fungi don't taste particularly bitter or smell obviously unpleasant at all. Some of the most lethal mushrooms in various environments around the world are described by people unfortunate enough to have tried them and survived to describe the experience as tasting genuinely pleasant, sometimes even described as delicious, right up until the serious symptoms set in. sometimes hours or even days later. This delayed onset danger represents one of the single hardest problems ancient humans had to solve, because if a dangerous food doesn't trigger any immediate negative reaction, and symptoms don't appear until well after the meal is finished and digested, the direct, immediate feedback loop that makes trial and error learning work reasonably well for most other threats simply breaks down completely. This is exactly where cultural knowledge transmission becomes absolutely essential, and it's genuinely one of the most underrated technologies our species ever developed, even though it doesn't involve any physical tool at all. Once someone in a group experienced poisoning from a specific plant, even with a significant delay between consumption and symptoms, that connection between cause and effect could still potentially be identified, especially if the same plant caused similar symptoms in multiple people over time, or if someone happened to notice the pattern linking a particular meal to a particular outcome. Once identified, that crucial piece of information didn't need to be relearned through fresh trial and error by every single subsequent generation. It got remembered, discussed, and deliberately passed down, transforming one person's genuinely costly, sometimes fatal mistake into permanent, protective knowledge for an entire community and every generation that followed. Let's talk about storytelling specifically here, because we touched on this briefly in an earlier video about ancient survival methods, but it deserves direct, focused expansion in this specific context. Vivid, memorable narratives. A particular plant that made someone violently ill, a specific mushroom that killed a respected hunter, a certain berry that looked deceptively similar to a safe one but caused serious harm, function as remarkably effective vehicles for encoding and transmitting exactly this kind of life or death information across generations without any written language required at all. A scary story, told and retold around a fire, deliberately structured to be memorable, emotionally engaging, and specific enough to actually identify the dangerous food in question, represents a genuinely sophisticated information storage and transmission system, one that modern researchers studying oral tradition have specifically pointed to as remarkably effective at preserving accurate, actionable safety information across remarkably long stretches of time, precisely because emotionally vivid, narrative-structured information tends to be remembered far more reliably than dry, abstract facts ever are. Now let's talk about something genuinely clever that shows up repeatedly across ancient human food knowledge: detailed observation of animal behavior as an indirect safety testing system. Ancient humans almost certainly paid close attention to what animals around them ate and avoided, using that observed behavior as genuinely useful, if imperfect, evidence about which plants might be safe for human consumption too. If a particular fruit was regularly eaten by birds, monkeys, or other animals without any apparent ill effect, that observation provided a meaningful, if not foolproof, signal that the fruit was probably reasonably safe for humans as well. This wasn't a perfect system by any means, since plenty of foods are perfectly safe for certain animals while being genuinely toxic to humans, due to differences in digestive systems and metabolic processing between species. But as one additional layer of evidence, combined with direct human experience and accumulated cultural knowledge, animal behavior observation likely provided a genuinely useful, low-risk way to narrow down which unfamiliar foods were worth the actual risk of direct human testing in the first place. Let's address something genuinely fascinating regarding processing and preparation techniques here, because this represents one of the most impressive pieces of accumulated ancient knowledge in this entire conversation. Plenty of foods that are genuinely dangerous or even outright toxic in their raw, unprocessed state become perfectly safe, even nutritious, once properly prepared through specific techniques developed and refined over countless generations. Various traditional food preparation methods around the world, soaking specific plants in water for extended periods, fermenting certain ingredients, applying particular cooking techniques, or processing foods through multiple deliberate steps, can neutralize naturally occurring toxins that would otherwise cause genuine harm if the food were simply eaten directly. The fact that ancient humans figured out these specific, often multi-step processing techniques without any understanding of the actual underlying chemistry involved represents a genuinely remarkable achievement in patient, accumulated experimentation. Someone at some point had to notice that a normally dangerous food became safe after a specific preparation process, remember that exact process accurately, and successfully transmit it to others precisely enough that skipping any crucial step wouldn't simply reintroduce the original danger. Let's talk about something genuinely important regarding seasonal and regional variation in this knowledge too, because ancient food safety knowledge almost certainly wasn't some universal, one-size-fits-all body of information applicable everywhere. Different environments contained entirely different plants, fungi, and animals, meaning ancient groups had to develop genuinely localized, environment-specific food safety knowledge rather than relying on some broader, universal set of rules that worked identically everywhere. A group migrating into genuinely new territory, encountering unfamiliar plants and animals their existing accumulated knowledge had never directly addressed, would have faced exactly the kind of fresh trial-and-error risk that established groups in familiar territory had already largely resolved through generations of accumulated local experience. This connects directly to broader patterns we've discussed throughout this series regarding migration risk and adaptation, suggesting that food safety knowledge specifically represented one of the genuine costs and challenges involved whenever ancient humans moved into genuinely unfamiliar environmental territory. Now let's bring in something genuinely fascinating regarding taboos and cultural rules specifically, because this represents another important layer of how ancient food safety knowledge likely got encoded and enforced within communities. Various documented traditional cultures around the world maintain specific, sometimes seemingly arbitrary food taboos. Rules against eating particular foods during particular seasons, life stages, or circumstances that researchers studying these traditions have repeatedly found often correlate with genuine, practical safety concerns, even when the explicit cultural reasoning given for the taboo doesn't directly reference toxicity or safety at all. A taboo framed in spiritual or symbolic terms might, on closer examination, actually function as a genuinely effective practical safeguard, discouraging consumption of a food that happens to be more dangerous during a specific season or more likely to be confused with a genuinely toxic lookalike during certain conditions. This suggests ancient food safety knowledge may have frequently traveled disguised within broader cultural and spiritual frameworks, rather than being transmitted purely as direct, explicit safety instruction, which actually makes a lot of practical sense. Since wrapping crucial survival information inside a culturally significant rule or taboo likely made that information considerably more memorable, more consistently followed, and more resistant to being casually ignored compared to a purely practical, unadorned instruction alone. Let's talk about something genuinely important regarding children specifically. Here, because food safety education almost certainly represented one of the most crucial, actively taught components of ancient childhood development we discussed in an earlier video. Children almost certainly learned what was safe and unsafe to eat primarily through direct observation and supervised practice, watching exactly which plants adults gathered and consumed and which ones got pointedly, deliberately avoided. This kind of embedded observational learning, repeated constantly across years of childhood foraging trips alongside experienced adults, likely built genuinely deep, reliable food safety knowledge well before any child would need to apply that knowledge independently, exactly the kind of patient, gradual skill transmission we discussed extensively in that earlier video. A child who spent years tagging along on foraging expeditions, watching which specific plants got carefully avoided, and occasionally receiving direct correction when reaching towards something genuinely dangerous, would have absorbed an extensive, practical mental catalog of safe and dangerous foods long before adulthood, built entirely through repeated exposure and careful, patient instruction rather than any single formal lesson. Let's bring in something genuinely interesting regarding testing protocols here too, because there's reasonable evidence and logic suggesting ancient humans may have developed at least some informal, cautious approach to encountering genuinely unfamiliar foods, rather than simply eating unknown items in full, immediately consumed quantities. Comparative evidence from various traditional foraging societies studied today shows documented patterns of cautious testing when encountering genuinely unfamiliar food sources, tasting tiny amounts first, waiting a period of time to observe any reaction before consuming more, sometimes specifically testing on an isolated patch of skin before actual ingestion for certain plants suspected of causing contact irritation. This kind of careful, incremental testing approach, while certainly not eliminating risk entirely, would have meaningfully reduced the severity of poisoning incidents compared to immediately consuming a large quantity of a completely unknown substance. And it's entirely plausible that ancient humans developed and culturally transmitted similar cautious testing behaviors, representing a genuinely smart, risk-mitigating approach to the unavoidable necessity of occasionally encountering and evaluating completely unfamiliar food sources. Now let's address something genuinely important regarding the role of specific recognized experts within ancient communities, because this connects to broader patterns we've discussed throughout this series regarding specialized knowledge and skill distribution. It's entirely plausible that certain individuals within ancient groups developed particularly deep, specialized expertise regarding plant identification and food safety, functioning as informal community experts whose accumulated knowledge and judgment carried particular weight and trust regarding which unfamiliar foods were worth the the risk of trying. This mirrors patterns documented extensively across traditional societies studied today, where certain individuals, often specifically older women given the typical division of foraging and food preparation responsibilities in many documented cultures, hold recognized, specialized expertise regarding plant identification, preparation, and safety that the broader community actively relies on and defers to. This kind of specialized expertise, concentrated within specific trusted individuals rather than evenly distributed across an entire group, likely represented a genuinely efficient way to manage and apply accumulated food safety knowledge, allowing the entire community to benefit from deep, specialized expertise without requiring every single individual to independently maintain that same comprehensive level of detailed plant knowledge. Let's talk about something genuinely fascinating regarding lookalike confusion specifically, because this represents one of the most persistently dangerous problems ancient humans had to navigate. And frankly, one that still causes serious poisoning incidents among careless foragers today. Plenty of genuinely dangerous plants and fungi closely resemble safe, edible varieties, sometimes differing only in subtle details that require genuinely careful, trained observation to reliably distinguish. This lookalike problem meant ancient food safety knowledge couldn't simply be a broad category list of "this type of plant is generally safe." It needed to include genuinely detailed, specific identification knowledge capable of distinguishing between closely related, visually similar species, some safe and some genuinely lethal. This level of detailed botanical discrimination, maintained and accurately transmitted across generations without any written reference material or photographic documentation, represents a genuinely impressive cognitive and cultural achievement, requiring exactly the kind of careful, detailed observational teaching and patient, repeated correction we discussed regarding how ancient children actually learned this crucial information in the first place. Let's bring in something genuinely interesting regarding meat and animal-based food safety specifically too, because this represents a somewhat different set of challenges compared to plant identification. Recognizing signs of spoilage or disease in meat, understanding which parts of certain animals might carry specific risks, and knowing proper preparation and cooking techniques to reduce parasite and bacterial risk, all represented genuinely important pieces of ancient food safety knowledge, separate from the plant and fungi identification challenges we've focused on primarily so far. We touched on cooking's role in expanding safe food options in an earlier video about fire, and that connects directly here as well, since proper cooking technique represented one of the most significant tools ancient humans developed specifically to make certain meat sources and certain plant foods too dramatically safer to consume compared to their raw, unprocessed state. Let's address something genuinely honest and important here regarding the limits of this entire system, because intellectual honesty throughout this series matters, and it would be misleading to suggest ancient food safety knowledge eliminated risk entirely or operated with perfect reliability. Mistakes almost certainly still happened regularly throughout ancient human history, despite all the accumulated knowledge, careful teaching, and cautious testing protocols we've discussed. Genuinely novel environments encountered during migration, unusual seasonal variations affecting normally safe plants, simple human error or miscommunication during knowledge transmission, and the inherent unpredictability of biological systems generally meant that even the most careful, knowledgeable ancient forager still faced genuine, ongoing risk every single time they gathered food from an unfamiliar source. This system reduced risk dramatically compared to pure, naive trial and error, but it never eliminated risk entirely, which is exactly why food-related illness and poisoning almost certainly remained a persistent, if reduced, danger throughout ancient human history, even within communities possessing genuinely extensive, carefully maintained, accumulated food safety knowledge. Let's circle back to something genuinely important, tying this entire conversation together. The cumulative, generational nature of this entire knowledge system represents one of the most genuinely impressive, underappreciated achievements in all of ancient human history. No single person figured out which foods were safe to eat through their own individual experience alone. This was an enormous, collective, multi-generational project, built through countless individual experiences, some pleasant discoveries of genuinely delicious new food sources, others tragic, sometimes fatal lessons about specific dangers, all carefully observed, remembered, and deliberately transmitted forward through storytelling, direct teaching, cultural taboo, and patient, supervised practice across literally thousands of generations. Every single piece of food safety knowledge any ancient human possessed represented the accumulated wisdom of countless people who came before them, many of whom paid a genuinely steep, sometimes fatal price to discover and pass along exactly the information needed to keep their descendants safer than they themselves had been. Let's bring this all the way back to our opening scenario, that young man crouched beside the unfamiliar mushroom, choosing caution over hunger despite his genuine uncertainty about exactly why something felt slightly off. Based on everything we've actually covered here, that moment of hesitation almost certainly wasn't pure, isolated instinct operating in a complete vacuum. It likely represented the accumulated weight of years of careful observation, half-remembered warnings from someone older and more experienced, the subtle, learned pattern recognition built through countless previous foraging trips alongside people who knew exactly what to look for, and quite possibly some genuinely vivid story, told around a fire at some point in his childhood about exactly what happens to someone who eats the wrong mushroom. He set it down not because he consciously calculated probability and risk in some formal sense, but because an entire community's worth of accumulated hard-won knowledge had quietly, effectively trained his instincts to recognize danger long before he could have explained exactly why. So how did ancient humans actually know what food was safe? Based on innate biological warning systems like bitterness and smell detection, painful but genuinely instructive trial and error passed down through vivid, memorable storytelling, careful observation of animal feeding behavior, sophisticated multi-step food processing techniques that neutralized otherwise dangerous toxins, embedded taboos and cultural rules that quietly encoded practical safety information. Patient, observational teaching directed specifically at children from a remarkably young age, recognized community experts holding specialized plant and food knowledge, and cautious incremental testing protocols. When genuinely unfamiliar foods were encountered, the honest answer involves an enormously sophisticated, deeply collaborative knowledge system, built and refined across countless generations that managed to keep an entire species reasonably well-fed and reasonably safe, despite navigating an environment containing genuinely lethal food sources at virtually every turn. It wasn't perfect. People still got sick. People still died from food-related mistakes throughout ancient human history, but the system that did exist, biological instinct combined with patient, deliberate cultural knowledge transmission, proved remarkably effective at turning an environment full of genuine, lethal uncertainty into something navigable, survivable, and eventually, across enough generations, even comfortably familiar. And maybe that's genuinely the most striking takeaway buried in this entire topic. Every single piece of food safety knowledge that eventually became completely unremarkable, completely taken for granted, which berries are sweet and safe, which mushrooms to avoid entirely, which roots need careful preparation before eating, started somewhere as a genuine, sometimes fatal mystery that someone, somewhere, deep in ancient human history, had to figure out the hard way, with absolutely no guarantee they'd survive long enough to pass along what they'd learned. The fact that any of that knowledge survived at all, accumulated patiently across thousands of years and passed down through nothing more than careful observation, vivid storytelling, and patient teaching, represents one of the quieter, more remarkable achievements buried underneath everything else our species ever managed to accomplish.